last lectures, and in structures we were talking about that there are two kinds of structure. One we call them as giant structures, and another one we call them as molecular structures. So then we talked about the giant structures. That giant structures are those structures in which we do not have a fixed number of atoms in a molecule. So we call them as giant structures. And molecular structures are those structures which consist of a specific number of atoms. So then we talked about giant structures and we divided them into different groups. One of them we talked about was the metallic giant structure. The second one was ionic giant structure. The third one we are going to study today, that is covalent giant structure. And the last one we will discuss is the molecular structure. In metallic structure we talked about that metallic structures are those structures which have a metallic bond, and the atoms have a strong force of attraction between the valence electrons and positively charged metal cations. Then we also talked about the metallic structures are good conductor of electricity. Then we also talked about they are malleable. They can be shaped into different shapes. Another one we discussed about the ductility, that metals are ductile. Magnets can be changed into electrical wires. You can make them wires. And they have very high melting and boiling points because they have a strong metallic bond. We have already discussed this one. Then we were talking about the ionic giant structures. That ionic giant structures, they have ionic bonding between them. And we have written three different definitions or three different topics. That was that ionic giant structures are crystalline. What do we mean by crystalline? So last time I draw a structure of sodium chloride, that actually sodium chloride does not exist in the form of molecules. Actually sodium chloride exists in the form of three-dimensional arrangement. So we have a sodium ion, and then we have a chloride ion. Then we have sodium chloride ion here, and then we have sodium. So these ions actually form three-dimensional arrangement. So we have sodium again here, and we have chloride here. And we have sodium here. So if you look at the ionic compound structures, they form three-dimensional arrangement. Their arrangement of the ions is three-dimensional. What do we mean by three-dimensional? So for example, we have sodium here. We have sodium ion, and this sodium ion is attracted by another chloride ion. Similarly, on the left side, this sodium is attracted by chloride ion. So in this structure, you can see that each sodium ion is attracted by two chloride ions. So this one we call it as one-dimensional arrangement. One-dimensional arrangement. Another arrangement is like we have sodium ion, and this sodium ion is surrounded on the right side by chloride ion, and then on the left side by another chloride ion, and then at the top by another chloride ion, and at the bottom by another. So in this kind of arrangement, every sodium ion is surrounded by four ions. So we call it as two-dimensional arrangement. But actually, the ionic giant structure, they have three-dimensional arrangement. What does that mean? It means that every sodium ion is actually surrounded by six ions. So we have sodium on the left, then we have chloride ion on the right, we have another chloride ion at the top, and another chloride ion at the bottom, another chloride ion on the front, and another chloride on the back. So we have actually total 6 ions. If you look at here, if you consider this sodium as a cation, so this sodium is attracted by the chloride ion on the right here. Then this sodium is also attracted by another chloride. So this is the second ion. 2. Third ion is at the top. This is the third one. The fourth ion is at the bottom. The fifth ion is from the back. and the 6th ion is at the front. So this kind of arrangement we call it as three-dimensional arrangement. So in ionic structures, if you look at this cube, so in this kind of arrangement, every chloride is surrounded by 6 sodium ion, and every sodium is surrounded by 6 chloride ion. So this kind of arrangement we call it as three-dimensional arrangement. Is that clear? Do you understand a little bit? So in ionic compounds, they have three-dimensional arrangement. And this kind of arrangement we call it as crystal, or we call it as crystal lattice. So now look at here, this structure well grows on and on. So this sodium, if you look at here now, this sodium is attracted by 6 chloride ion. One is here, this is the second one. The third one is here. The fourth one is at the bottom. The fifth one is in the air. I cannot show it here. The fifth one is here. And the 6th one is behind the board. So this is called three-dimensional arrangement. That each ion is surrounded by 6. We have total 6 signs. Right, left, top, bottom, front and back. So everything has got 6 signs. Is that clear? So in this kind of ionic compound, if you look at here now, we have chloride on here. So we have 4 now. 1, 2, 3, 4. Similarly, this sodium, this chloride will be surrounded by 6 sodium. So 1, 2, 3, 4 here. The 5th one can be at the front, and the 6th one will be behind the board. But we cannot draw it here. I cannot draw in the air. So I can only show you that the 5th one is at the front and the 6th one is behind the board. So in ionic joint structure, each ion is surrounded by 6 opposite ions. So if you have chloride ion, it will be surrounded by 6 sodium ion. So if we have positively charged sodium ion, it will be surrounded by 6 chloride ion. So they form this kind of structures. So this kind of structures we call them as crystal lattice, or we call them as that ionic compounds are crystalline. They are what? Crystalline. So the second thing is, last time we talked about that ionic compounds are crystalline. So what I mean by crystalline, that every ion will be surrounded by 6 opposite ions. The second thing, now you look at here, that ionic compounds are ionic joint structures. Ionic joint structures are brittle. Brittle, what do you mean by brittle? Brittle means easily broken. In chemistry we call it as easily broken. So what do we mean by easily broken in chemistry or brittleness? Now if you look